Hello everyone. Today we're diving into the application of differentiation, where you use DYDX to solve questions. In today's questions, we'll be looking at how to use tangents, find the normals, maximum, minimums. In this video, we'll go through some key example questions, breaking down the step by step so you can see exactly how to apply DYDX in different scenarios. Okay, let's get started. For the first question over here, the equation of the curve is y equals to kxe to the power of negative 2x, where k is a constant. Find dy dx. So to find this, all we have to do is use product rule. Remember to break it down from one side to the other, left and right. Differentiate left, we will have just k. Imagine k as just a random number, okay? Then copy right e to the power of negative 2x plus differentiate right, differentiating exponential. Over here, we'll get negative 2, then e to the power of negative 2x, copy left, kx, right? Now, from here, all we have to do is simplify the equation and factorize out the like terms. So we have both e to the power of 2x and k on both sides. So I can just take out k to the power of k e to the power of negative 2x. And I'm left with, inside the bracket here is 1. Inside the bracket here is minus 2x. Okay, first part here, very simple. In the next part, find the coordinates of the stationary point on the curve for y equals to 10x e to the power of negative 2x. Now, look at this question here. This is actually the same as what we previously had. But instead of it being k previously, now it's 10. And to find the stationary point, we always have to let dy dx equals to 0. So since we already have dy dx here, instead of k, now it's 10. You have dy dx is actually equals to 10 e to the power of negative 2x, then bracket 1 minus 2x. Then let dy dx equals to 0, 10 e power negative 2x, 1 minus 2x is equals to 0. And from here, what you're going to do is you're going to bring this to over to divide, and ultimately you just have 1 minus 2x is equals to 0. Therefore, x is equals to 1 over 2. Now, since you're looking for the stationary point, you have your x coordinate. All you have to do is substitute your y coordinates, substitute your x into your y to find the y coordinate. So you would have y is equals to 10 to the power of, 10 times 1 over 2 e to the power of negative 2, 1 over 2. Type this value into your calculator, you would have 5e to the power of negative 1. Okay, or you can write it as 5 over e. Okay. In the next question, a curve has an equation of y equals to 3x squared minus 5 to the power 1 over 3 over x plus 4. Show that dy dx can be written in the form of ax squared plus bx plus c over this whole thing here, where a, b, c are integers. Meaning to say, they just want you to format your dy dx properly. So differentiating this question over here, this will be a quotient rule. First off, you have to differentiate top, 1 over 3, 3x squared minus 5, then minus 1, so it's negative 2 over 3. Then differentiate what's inside, you have 6x. Differentiate top, copy bottom, x plus 4, minus differentiate bottom, which is just 1, copy the top, which is this whole thing here, 3x squared minus 5 to the power of 1 over 3. over the bottom square. So x plus 4 square, right? Now I have to rewrite this as a fraction and simplify where I can. So simplifying this would actually be, 2. Expand the brackets here, 2x times x, 2x squared plus 8x over this thing, right? 3x squared minus 5 to the power of 2 over 3. Now this I have to minus with 3x squared minus 5 to the power of 1 over 3. What we're going to do next is I'm actually going to combine the denominators together, which will then become 2x squared plus 8x minus this times this. 3x squared minus 5 to the power of 1 over 3 times with 3x squared minus 5 to the power of 2 over 3 over the whole thing, which is 3x squared minus 5 to the power of 2 over 3. Now, this value dividing this value would just mean that they would actually be the same denominator together. Okay. So from here, just simplify where I can. 2x squared plus 8x. This 1 over 3 plus 2 over 3 will become 1. So I just have to expand this, which will be minus 3x squared plus 5. Okay. Over the denominator, which we don't have to expand. And finally, just simplify it and rewrite it in the format that the question wants you to have. 2x squared minus 3x squared, negative x squared, plus 8x, plus 5. Okay. Over the whole thing. 3x squared minus 5 to the power of 2 over 3, x plus 2 squared. Oh, sorry, x plus 4 squared. Why did I write 2? Okay. And then this is according to the format of the question. Right. Now, in the next question, hence, find the x-coordinate of the stationary point on the curve. Give your answers in their simplest exact form. Meaning to say, you are only supposed to show all your working without typing it into the calculator, right? So, using the same logic from previously, stationary point means DYDX equals to 0. This is your DYDX minus x squared plus 8x plus 5 over the whole thing over here, 3x squared minus 5 to the power of 2 over 3, bracket x plus 4 square equals to 0. What's going to happen is, when you bring these numbers multiplied to the 0, it's still 0. Therefore, it is just straight away x squared plus 8x plus 5 equals to 0. Now, since they want it in exact form, you could type it into the calculator and then you will get the x values which are equals to decimals. Or to find the exact form, what you're going to need to do is identify that this is a quadratic equation and use your quadratic formula, for which x is equals to negative of b plus minus the square root of b square minus 4ac over 2a, right? Simplify from this, you have negative 8 plus minus 64 plus 20. So this will be 64 plus 20 square root of 84 over negative 2. Then from here, simplify them because they are all divisible by 2. So first of all, change this into square root of 4 times square root of 21, right? Square root of 4 square root of 21, this will give you square root 84 minus 8, which this is actually equals to 2, yeah? Sorry. Then from here, factorize out -2, not just 2. Factorize out -2, you're left with 4, then minus plus. This is also equals to 2, right? Square root of 21 over -2. Cut this, cut this. Your final answer is just 4, plus minus minus plus, square root of 21. So these are your answers here. Or you can just write them 4 plus square root of 21. X is equals to this, or x is equals to 4 minus square root of 21. Done. Okay.